Quantum mechanics has a reputation for being full of bizarre interpretations. Many worlds, Bohmian mechanics, objective collapse, Copenhagen, hidden variables, consciousness causes collapse. The list goes on. To someone first learning quantum mechanics, it can feel like a zoo of completely unrelated ideas. But the more I studied them, the more I realized that at a very high level, most of them fall into just two families. The first family says that something fundamentally new happens during a measurement. The wave function, the mathematical object that describes all possible outcomes, actually collapses. One possibility survives, the others simply disappear. The second family says something much more radical. Nothing disappears. The wave function never collapses. The Schrödinger equation keeps working exactly as it always has. Every branch continues to exist. Physicists call these the no-collapse interpretations. Among the most famous are the many worlds interpretation and Bohmian mechanics. At first glance, these two seem completely different. Many worlds says reality branches into countless worlds. Bohmian mechanics insists there is only one world with particles following definite trajectories. Most textbooks introduce them as rivals. But then I noticed something that I cannot stop thinking about. Maybe they are much closer than they appear. Let's see why. Imagine Alice measures the spin of an electron. In a collapse theory, only one outcome survives. If Alice saw up, then the down possibility is simply gone. End of story. But in a no-collapse theory, something very different happens. The wave function evolves into multiple branches. One branch contains an Alice who saw up. Another branch contains an Alice who saw down. Notice the wording I used. I did not say there are two actual Alices. I said the wave function contains two observer branches. That distinction turns out to matter, because now the two no-collapse interpretations part ways. Many worlds says every observer branch is equally real. Every Alice exists. Every Alice is conscious. Every Alice sincerely believes she is the original. Bohmian mechanics tells a different story. The wave function still contains both observer branches. Nothing has disappeared, but only one branch contains the actual particle configuration. The other branch is called an empty wave. It is not erased. It is not destroyed. It continues evolving according to exactly the same quantum dynamic equation. And that was the moment something clicked for me. Maybe these two interpretations are not telling completely different stories after all. Many worlds has many occupied worlds. Bohmian mechanics has many branches too, except only one is occupied. The many worlds theory has empty worlds. The Bohemian theory has empty waves, different ontologies, the same underlying quantum evolution. Now, if you are an Everetian or a Bohmian, you are probably already preparing objections, and that's fair. Each interpretation has deep philosophical commitments that the other rejects. I am not claiming they are the same theory. I am only pointing out something that surprised me. Once you reject collapse, the mathematics insists on keeping all of the branches. The real disagreement is no longer about what the wave function does. It's about what those branches mean. That realization made me think of one of the strangest thought experiments in modern physics. The Frauchiger-Renner experiment. I talked about that experiment in an earlier episode. Now let's very briefly review it. Imagine Alice performing her quantum measurement about a particle inside a perfectly isolated laboratory. Inside the lab, everything feels completely ordinary. She sees a definite outcome, like spinning down. She writes it in her notebook. She remembers it. From her perspective, nothing mysterious has happened. Now imagine another physicist outside the laboratory. Instead of opening the door and asking Alice what she observed, he performs a quantum operation on the entire laboratory. Not just the electron, the whole laboratory, including the particle being measured, and Alice herself. And remarkably, quantum mechanics predicts that this operation can restore interference between the previously separated branches. The branches corresponding to Alice seeing different outcomes, one spinning up and another spinning down, have not simply been ignored. They can become, quote, unquote, real. Again, this is one of the reasons the experiment is so unsettling. In Bohmian mechanics, the so-called empty wave was not merely a discarded possibility. If it had truly disappeared, there would be nothing left to interfere with. So, the empty wave where Alice would have seen spinning up can become coherent with the actual wave where Alice had seen spinning down. In many worlds, the interpretation is even simpler. The different worlds become coherent once again. Different language. The same quantum evolution. Again, I found myself wondering, perhaps these theories are shadows cast by the same underlying mathematics. But then I realized there was one place where they might truly differ, not in the equations, not in the predictions. In the meaning of the word, I imagine that after a quantum measurement, there are two versions of you. Both have identical memories. Both think they are the original. Both laugh at the same jokes. Both remember deciding to watch this video. Which one are you? Most supporters of many worlds answer without hesitation, both. You have branched. There is no unique continuation. There are now two equally real future versions of you. That is the orthodox Everett picture. But I have to admit, I've never found that psychologically satisfying. When I imagine myself tomorrow, I don't imagine becoming two centers of awareness. I imagine becoming one. There always seems to be one point of view, one silent witness behind the eyes, one stream of experience. Maybe that is just an illusion. Maybe evolution never prepared our brains to imagine branching identities, or maybe our intuition is pointing towards something real. Suppose consciousness doesn't branch. Suppose every branch contains a complete physical copy of you. Every memory, every neuron, every heartbeat, every sentence. But only one branch carries your present stream of awareness. The others are physically complete. They would insist they are conscious. From the outside, they are indistinguishable. But from your own first-person perspective, they are empty. Not empty because no one is there. Empty because you are not there. And suddenly my earlier comparison returned in a completely new form. In Bohmian mechanics, one branch is occupied by particles. Perhaps consciousness occupies one branch in an analogous way. Not because physics says so. Physics says nothing about this. This is philosophy. But it is philosophy inspired by physics. Now go back to the Frauchiger-Renner experiment. When the outside observer performs that extraordinary quantum measurement, what comes back together? The worlds, the waves, or merely different physical descriptions, while the stream of awareness quietly continues along a single path. Perhaps consciousness never split. Perhaps only the mathematics did. I don't know the answer. I don't think anyone does. But what fascinates me is how a technical debate about quantum mechanics quietly transformed into a question about personal identity. Who am I? What makes tomorrow's version of me still me? Can consciousness branch? Or is there always a single observer traveling through reality, while the universe around it blossoms into countless possibilities? Physics may never answer those questions, but every so often, physics shines a light into places where philosophy has been waiting for centuries. And sometimes, the most profound discovery isn't about the universe at all. It is about the mysterious voice inside your own mind that has been saying the word I your entire life.